Hi guys and welcome back. So today we would be studying about bounded sequences. Now in my previous videos I explained you about upper bound, lower bound and supremum and infimum. So here we would be talking about bounded sequences. So the sequences can also be bounded. So let's see how. So this is the first definition. This is the second definition. This is bounded above definition and this one is bounded below. So the first definition goes like a sequence xn is bounded above if there exists m which belongs to real number such that xn is less than equal to m for all values of n belongs to natural number. The number m is called upper bound of xn. Now if you might have carefully understood my previous explanations, then it is very simple to understand. Bounded sequences is nothing but the same thing again being repeated, only it is that here you can see there's a sequence, and in my previous definition it was not a sequence, it was a set. Other than that, the entire definition is kind of same, so I'll just go through it quickly. So it says that a sequence xn is bounded, which means it is bounded above. Okay, now why it says bounded above, you would come to know if there exists m which belongs to real number. Now it says that m is an element and it belongs to real number, and then there is also a sequence that is xn. Okay, and the sequence xn is bounded by this element. When it is bounded, when it is less when it is greater than equal to xn, that is when xn is less than equal to m. Okay, so when this element is greater than equal to xn or all the elements of this sequence, then m is said to be bounded above. Okay, now they say further that for all values of n belongs to natural number. Now you'll ask what this is. It means nothing but that for all values of n belongs to natural number. This n you can see here, right? So this n would be replaced by natural numbers which begins from 1, 2 and then so on, right? These are the natural numbers. So when n belongs to natural number, under this condition and this condition, m will be said to be the upper bound of sequence xn. Then it further says that the number m is called upper bound of xn. That's what I said. So when m becomes the upper bound of xn, then it is also said that sequence xn is bounded above. Okay, so you can say it either way. Sequence xn is bounded above or m is the upper bound of sequence xn. Okay, it basically means the same. You're just referring to different elements. Then same goes for bounded below. So a sequence xn is bounded below. So again there is this sequence xn, then they say it is bounded below if there exists m. Now you have this m which is an element, and this element belongs to real number, and this element belongs to real number such that there's this condition which is given, m is less than xn. When this condition becomes true, then we say that m is the lower bound of sequence xn. Okay, then we say that m is the lower bound of sequence xn. So what does this mean? So when I'll just show you, the elements of sequence xn can be anything. So let's just write x1, x2, x3, x4 and so on. When all these elements are greater than equal to an element m, and this element m belongs to real number. Okay, when all of these elements are greater than equal to an element which belongs to real number, then this condition is true, right? So that's what I'm explaining you. Then we say that this element becomes the lower bound of the sequence xn. And then it can also be said that sequence xn is bounded below. It is bounded below by what? It is bounded below by this element m. Fine. So here we can see that these two conditions. Okay, so these are the two conditions which we got from above. So you can basically write it as something like this. Makes sense, right? So we can say that M is the lower bound and capital M is the upper bound. This is how it is written, which means that when there exist both lower and upper bound of a sequence, then this sequence is said to be bounded sequence.